Hi, I'm Randall. You might know me as...
Randy, where are you? Randy.
Yeah. Hang out with Captain Q long enough, and you'll end up buying a boat. And I'm no exception. So join me as I navigate the ups and downs of owning an old sailboat. So today's going to be kind of a fun little side tangent, thanks to YouTube. I got an email from a colleague at Edson Steering Systems, and he said he had seen the first episode and was curious as to how deeply I looked at the steering systems. And I said, not really at all. I mean, I've seen them, I know where they are. I don't know really what to look for. And he said, I think I might be able to help you take a look at things and do a little bit of an analysis. I'm right down the road from you, from where you keep the boat. So why don't we check out your steering systems and see what kind of shape they're in, and maybe there's some opportunity to make some enhancements or improvements. So anytime someone wants to help out and provide some advice to help me learn, I think that's great, and I'm interested to see what he says. My guess is it's okay, but it'd be great to have an expert come take a look. So Dave is just about to show up. I'm going to go greet him at the boat and get started. Dave, welcome aboard. Thank you so much for reaching out. What do you see a lot of when you're looking at old boats like this?
So a lot of what you have on this boat could be replicated today. It's still in production. It's pretty simple stuff, and it's very modular. The things that we see on boats of this age, and this is center cockpit, so it's it's going to have probably a long and pretty interesting cable run back to the rudder post. What we see is kind of wear items. We'll have a chain that we don't know how that looks. We'll have cables that, how long have they been in service? A lot of the sheaves, any of the moving parts. And then we want to take a look at the quadrant.
What is a sheave, and then what's a quadrant?
Good question. So a sheave is like a block. So it's just cable running through those, and typically it's wire. Sometimes it's cordage, but typically it's wire. On this boat, I'm going to guarantee that it's wire.
Yep.
And so sheaves are just used to change direction of the cable and get things around what they need to get around and get them where they need to be.
Okay.
And then a quadrant looks like a slice of pizza, and it's attached to the rudder post, clamped on, and the cables terminate by going across that.
What do you see with problems with the quadrant and problems with the sheaves?
So the sheaves ride on one bearing pin in their center.
Okay.
And over time, those can get worn constantly under load in one direction. Gotcha. It's not moving under high speed, but it's under high load, low turns.
Yep.
So those pins can get worn away. You want to look at the cheeks of the sheaves, which are, again, looking at a block, kind of like the sides.
Yep.
And if those are abraded, that would mean that either there was misalignment in the cable runs, or oftentimes the cables are too loose, so it'll dip. And when you turn, you have a pull side and a slack side.
Yep.
And as you go, as you transition from a side being the slack side to the pull side, if the cable isn't tight enough, then it will sag and it'll kind of abrade the cheek of the sheave as it goes into it. So those are the big typical problems there.
Okay. Cool. Well, that's a good introduction. So I think maybe we should jump in and go take a look.
Let's go.
All right. Has found the fun spot to get through the engine room through the tub.
It's neat to be in the tub doing this. So this idler plate here, which has the sheaves on it, as promised, is a little bit unusual because these sheaves are parallel to one another. Normally that's not the case. But this is the backing plate to the pedestal right here. And as I said, this is all stuff that's still in production. Here we have the cable, and it's running to those two side-mounted sheaves. And it looks like the alignment is actually great.
What do you look for when you're talking about alignment?
So the sheaves have really deep wells in them, And you can see that these cables are not hitting the sides of the sheaves at all.
Okay.
There's, basically equidistant between the two walls of the sheave, and that's really good to see. Similar on that one.
Yep, nice and deep, plenty of space.
Yeah. So, and the chain tension seems really good. You don't want to be able to play a musical note on it, but you don't want to have any obvious drag at all.
Okay.
And this tension looks really quite good. One trick that we've come up with is to take either some tissue or a cotton ball and just run it along the cables.
And you're feeling for a
just
snag.
Feeling for meat hooks.
Yep.
It's a lot nicer than doing it with your fingers.
I think Captain Q uses his hands and he looks for blood afterwards.
Yeah, that's not the best way. So that's good. But then we're going to have these two cables going back along the starboard side of the boat.
Yep.
And we'll see where they wind up.
All right.
The
So we're just going to follow that back.
Yep.
All right. Anything else here that you would look at? I think you mentioned cotter pins at some point, right?
Yeah, so these are the sheave pins that we were talking about, and this boat is old enough that those would have been made out of brass, which at the time was thought to be more self-lubricating. It's oil-light material.
Okay.
And they drink up oil. Actually, they have like capillary wicking to get oil in them. So you would put oil in them and they would self-lubricate and be that way for a long time. The problem is that over time, they, it's a softer material than steel. So eventually, under that constant tension, those get worn away. And what we're going to want to do is drop the cable tension down and check those out for play, because it'll be somewhat obvious that the sheaves will move around.
Okay.
We can see that this has been greased here, which is good. But again, the lubrication of these things is best through oil. Grease is too viscous for the material to soak it in.
Yeah. And
So
what kind of, is there a particular kind of oil or?
I think 30 weight's the best.
Okay.
Just
Which is
like oil,
engine
flavored
oil, yeah, for the old engine.
Yeah.
Yeah.
Exactly.
Next step is to trace that back on the starboard side.
Yeah. There we go.
Let's do that. All right. So here we are. This is the starboard side aft bunk.
We have another pair of idlers and sheaves here. Same thing. We have, well greased. Kudos for that. But again, those do like oil rather than grease. It's more drinkable. Again, the alignment looks quite good. We can see some kind of staining on the cable right there. That's probably grease, but our typical recommendation is just 10 years of service life for a chain and cable in salt water, since it does get crevice corrosion over time.
Okay.
Which is the salt water getting in and rotting the metal from the inside out.
Oh wow.
You don't want to have your steering system fail.
No.
It chooses always the worst time.
Yeah, it doesn't happen at the mooring usually.
No, it doesn't. And similar with engine control cables, it's always when you're pulling into Block Island Boat Basin on July 4th that those things decide to go.
Speaking from experience,
You get a big crowd. So in general, we're probably, given the age of everything, we're going to want to change the cable and the chain. We're probably going to want to service the idler sheaves and put some new pins in there. We'll definitely check out the pins, but I'm guessing that those are going to want to get replaced. But again, the layout of the system looks really good, and it looks like it's been maintained. So, no obvious filings of any sort, no bronze dust anywhere. So that's a good sign.
And would you do the TP test here as well, I presume?
Yeah, you would do it, anywhere you could access it.
Yep.
And you can turn the wheel, and that will expose new cable to you from one spot. So if you were having trouble accessing it, you could turn the wheel and get
turn
the
to
cable.
turn, yeah, all the way over.
Exactly.
Okay, cool.
Yeah.
And so it looks like we have one more stop before we get to the aft rudder post.
Yep.
All right.
So we have one of the steering cables terminates in this chain here, which is sharing an axle with this ancient wood Freeman Pilot, which in its day was the absolute bleeding edge, the best you could buy, but its day is a couple days ago.
It's like the prototype for the autopilot, right?
And one of the big disadvantages of the old style of autopilot like this is that with a newer autopilot, you have a ram drive, typically, and you can have a separate autopilot tiller, which will be either above or below the quadrant. It'll share the rotor post with the quadrant, and that gives you a wholly separate steering system. So if your cable was to break, or any, chain break, or one or the other systems break, you have an entirely separate system. This one, if one of them goes down, they're both go. Well, if the main steering goes down, then everything's down. Looking at the quadrant, we can see that it's been brazed in one spot, two spots. It's been repaired.
Interesting.
You can see that both by the brazing spot and the corrosion. So you can tell that this quadrant at some point has been damaged, and the way it's been repaired, it was good for getting you through, but that will create a stress riser there.
How do you think a quadrant would get damaged?
There could be a lot of ways it could happen. One of the worst things that happens to a steering system is if you're in reverse and you drop the wheel. Sailboats have gigantic rotors on them, and you turn that barn door catastrophically in one direction and smash. So that's one thing can happen. Groundings are another thing that can happen. If you leave the boat on the mooring and the wheel isn't captured in any way, a lot of people use the brake to do that. It's better to do it with sail ties and do it that way, because the brake's not really meant to handle that.
That kind of load,
Right, but if you have, either way, the point is you want to prevent the steering system from swinging around all over the place and getting bounced all around. You want to kind of, really the thing to do is have good effective rotor stops.
Yeah.
And this is one good method there.
Is wood the best, or is there something more?
Wood's good because it absorbs, but there's also chain or rope mounted ones that work well. There are a bunch of different ways you can do it. Good to have some shock absorption, which obviously the wood does. We sell a thing called the bungee, which is this kind of urethane rubber attenuator for cable. So as it gets stretched out, it
gives you that resistance.
Gives a little before it hits the stop.
Yep.
Any of these can work, but the most important thing is to have one.
Yeah.
Because this, in the worst case, you could really do some damage to the bulkhead too.
Oh yeah.
So any of those things could have caused this, but really what the recommendation here would be is to put a new quadrant on. And this is a reasonably big quadrant, but nothing out of the ordinary. It's a pretty standard rotor post diameter. You can see it's got the keyway along the post down there. So that's the second, you have clamping force here.
Yep.
These are machined to a tight tolerance, to a couple thousandths onto the rudder post, and that provides a good base. But then to give the positive stop from it rotating on the post, you have the keyway there.
Okay.
And that's one, you can have a set screw, you can have a through bolt, you can have a keyway. I think the keyway is probably the best way, and that's what you have.
Simple mechanical.
Yep.
Any concern about what's happening with the chain from this autopilot system? Like what's going on the port side here? What if I follow that chain over?
Well, let's go have a look at the port part. Steering cable is on this thicker chain, which is number 50, it looks like. And then we have a smaller chain that's driving the autopilot on this sprocket here. And they're all both on one axle. And it's in its day, again, it was great, but things have moved on a little bit.
Yeah, I mean, is this typical? Have you seen this before, this type of arrangement?
Yeah. This is, what you would have on a boat of this of this age that was doing some serious cruising.
All right.
But one of the interesting things that you'll have on this is an analog compass.
Oh wow.
With pickups for an angle indicator, and that tells the autopilot where you're going. It's got some great advice.
Oh yeah. There we go.
So
as far as removing the autopilot system, the compass and all that, is it going to be pretty straightforward as far as removal and then replace it with just a much simpler system?
yeah, it will be. So the cables have to come into the quadrant from opposing directions.
Yep.
But we've got that covered by this base right here. What we can do is put a flat plate on there with a sheave on it.
Yep.
And that will take care of the turn. That will all become one length of the new cable, and then that sprocket would just go away.
Oh.
And then it would just be ready to go.
So that would mount to
this bulkhead right here.
Okay.
We have bases that will mount right onto that bulkhead. No sweat.
Okay.
It'll look like it was designed that way from the beginning.
I'll have a lot more storage, I think.
Yeah, you will.
So overall, what kind of grade would you give this system?
For its age, it looks like it's in great condition. There are just some, 10 years is about the lifespan of a chain and cable. This one looks like it's in pretty good shape, but you don't want to leave that to just trust.
Right.
When you're out there doing what you're going to want to do with this. So we'll want to take some, maintenance and preventative care to it, but overall the system is ready to be brought up to spec. There's no gigantic problems other than the quadrant, which is relatively easy to replace.
Right. Are they pretty standard sizes too?
Yeah.
Okay.
Yeah.
Okay.
We have
Since the rudder stock is a standard size, you'd have a standard.
We bore those out. Their rudder stocks come in almost an infinite number of diameters.
Oh, okay.
But we have the machine shop and we just bore those out to suit. We'll take a caliper and figure out the rudder post diameter. Have the guys bore out a new quadrant. And
It sounds pretty cool. Is that something I could come check out at some point?
You
Yeah.
should.
All right. Sign me up.
All right.
I want the tour.
You got it.
All right. Well, what are the next steps? I mean, do we need to do like a little schematic or a bill of materials or?
Yeah, I think we'll put together a materials list. Try to get an idea of the cable lengths that we're gonna use. We need to get into the pedestal to get the chain length.
Yep.
And it's pretty straightforward from there.
The only other question I have for you is about the future autopilot.
Yeah, good question. So we have a lot of keyway exposed on top of the post.
And keyway, you mean that segment that has the keyed out section?
Exactly.
Okay.
That the quadrant's sitting in right now.
Yep.
And it looks like we probably have plenty of space to put a new autopilot arm,
Okay.
which is a cast bronze, probably be a 12-inch on this.
Okay. And then you'd have to mount the ram somewhere above.
Yeah, probably a shelf somewhere along this aft bulkhead
Okay.
for the pilot drive, and then it will come out and meet the arm somewhere in this area here.
So something I should glass in, build and glass in.
It wants to be solid.
Yeah. Yeah. You do not want that moving at all.
Driving the boat.
We are back for phase 2 of the steering evaluation and refit. So last time Dave from Edson came out and did a quick evaluation, went back and figured out what bits and pieces we were going to need to do a full and proper refit. And so now we're back in the next phase, which is to take some measurements because the rudder post has got to be, I think, within several thousandths of an inch to mate with the steering quadrant. So Dave's on board. I'm going to go back and check our access and help him do some measurements, and we'll learn a little bit about that. All right.
Hey,
Hey, welcome back, Dave.
thanks.
So you're in the aft cockpit here, and we've got some pretty unique access, which I learned when I was getting the boat set up. Is I've got an emergency cover here, which we've undone with this specialty tool here, and that tool just kind of pops in and unscrews this little cap. So if you need to get at the rudder stock immediately, you can do so. And I've got an emergency rudder post that is has the notch. What would you call that?
The key.
The key parts that go onto that rudder stock. So if you lose your cables, your steering, you come back here to the aft cockpit with your emergency steering post and tiller and hook that on. This also has a couple of screws for a giant manhole cover, which is going to unveil this.
Absolutely A++ access here. You never get this. It's never this easy on any boat.
You can't really walk into them like this one?
No, but we'll enjoy it.
So what's the first task that we're going to do here?
So we've identified that, now we can see the fix that was done on this quadrant much better. So we're going to replace the quadrant, which means that we need to know how big this quadrant is in the radius and also how big the bore is. And we measure the bore very accurately out to 3 decimal places, thousandths of an inch.
Wow.
And you want to get a nice tight tolerance fit on there. So it's basically two things that hold it together. You have the key, which you see right here. And that is the preferred way to do this. There are really 3 ways to secondarily keep the quadrant and the post aligned. The first is the key, which you have here, so that's great.
Okay.
The next is a through bolt, which would go, through.
Yep.
And then the third is a simple set screw.
Okay.
And all 3 work, but the key seems to be the preferred method. But that's, in concert with this very tight fit. You can see that the quadrant, you can barely see the part line between the aft end and the front of the quadrant, and that's because this was originally bored to a tight tolerance like we're going to get the next one.
Yep. And that basically means that the other parts of the mechanism don't have to do as much work if that tolerance is really tight.
Right.
And so there'd be less movement, less wear and tear.
Yeah.
Okay.
I mean, we certainly don't recommend it, but we actually just last week were contacted by a catamaran that had their quadrant come loose. And it was with just no secondary method at all.
Yep.
It was just the clamping tolerance and red Loctite.
Okay, wow.
And it had held it in place for like 15 years. Again,
all right.
Don't do that.
Yeah, not recommended, but all right. So we've got the key, and you're going to take some caliper measurements.
Yeah, and what you want to do is measure with a good digital caliper.
Are you going to measure in millimeters or imperial?
I'm going to measure in imperial.
Okay.
Yeah, so I'll get down there. And you want to measure, in a couple of different places, all close to where the post is going to go. And you want to get it as, close to perpendicular and square as you can. Close to dead on too, but yeah, so we're seeing 1.9985. So we use that 1.99, 1.98.
Yep.
Split them in the middle.
Yeah.
That's close enough. Everything has a little bit of a tolerance.
Would that have started out at 2 and there's
Likely.
wasted over time?
Yep.
And what material is that going to be?
This is bronze.
Yep.
Which is somewhat unusual. A lot of time they're steel, a lot of time they're aluminum.
Yeah.
On a lot of J-boats, they're composite.
Okay.
Which is a different way. They're not round.
Right,
usually
right.
when they're composite.
Interesting.
Yeah. So with the composite ones, they're lighter, but also one of the big features is they want to build skinny rudders.
Yep.
For lower drag.
Sure.
And so you can get, a narrow profile. So they're oblongated, rectangle.
And so how do you clamp to that?
We do a rectangular bore.
Okay.
And, about spar tight. which is what you...
I don't, yeah.
So Spartite's cool stuff. It was invented to seal the gap between your keel step spar and the deck.
Yep.
And it's just this kind of urethane.
Yep, flexible. Yep.
Yeah, it comes out, like, dries to like a skateboard wheel.
Yep.
And so what you do with the composite is you get the quadrant on.
Yep.
And then you pour Spartite in, and that fills up all the gaps. And it's
good enough.
A great attachment thing. So that works out easily.
Cool.
So now we've got that measurement, which is the post, and that's good. That's, no big surprise there. And now we want to know the radius of the quadrant.
Okay.
And this is a pretty big one.
Yeah.
This might be an 18 or a 20. And simply, this isn't nearly as exacting a measurement because they're in 2-inch increments. So, if we get to that, so this is a 14. I'm measuring on the outer lip, but properly you want to measure from the, there's the 14 measurement. You got that?
Yep. So it's 14 from
inside the groove.
Oh, okay.
From the bearing point of the groove, which we can see if we go inside. There is one thing I'd like to point out here that's actually kind of bad, which is that these nuts are both supposed to be on the back side. This second nut is to lock this one. So you do the adjustment here and then lock it on. So good to look at that, because now this one, if this one was to back off, which is what you want to prevent, it would have nothing holding it.
Right. That second one isn't really doing anything.
Yeah. So now with those two measurements, we know what quadrant we're going to use.
Okay.
We know the keyway orientation is going to be dead forward. That's called. And the key can be kind of anywhere on the post, but normally it's dead forward or dead aft.
So next step is you're going to have the machinist at the machine shop work on the quadrant with that tolerance.
Yeah, so we have quadrants on the shelf that are poured in the foundry.
Yep.
And then each one gets custom bored as it's ordered. Once it's custom bored,
that's
you
yours.
Can't unbore it.
Well, I'm looking forward to checking out the shop. Do you mind if I come by the shop and check out that process?
Yeah.
All right, that'd be kind of fun. All right, thanks, Dave.
Thank you.
All right. I just wanted to give special thanks to our friends and supporters at Edson Marine, and also for taking time out of their busy schedules to come by the boat, walk me through some things, help me learn a whole bunch. Hopefully everyone watching has learned as much as I have over the past several weeks. So thanks again.